Hi, my name is Neil Joshimpulli, and I'm bringing you this mini lecture on relational databases with MS SQL Server for beginners. This is just an overview of database data structure and doesn't go into much detail on everything, but I'll give you a high-level overview of the different options you have, the different ways to separate out a database and the reasons why. Commonly asked questions with concerns to databases is: what is a database? Why are they useful? Where are they used? How do you implement them? Why are so many databases implemented incorrectly? Why are they so complex? What are some popular database engines? So what is a database? Basically, a database is an information repository. It allows you to contain and access vast amounts of information via a database management system. Why are they used? In this world with more and more information being at our fingertips, it's hard to be able to iterate and access all this information. So databases provide a method of organizing this information and easily accessing it in a quick and efficient manner. Where are they used? Well, databases are used everywhere. Any company that is developing realizes that knowledge is power. Consequently, the more knowledge that you manage and have access to quickly and are able to access quickly, the more of an advantage you would have in the quickly developing market where knowledge really has an influence and can make or break your company. How do you implement them? Well, there are a lot of ways to implement them. In order to implement them, of course, you could use existing software suites like Oracle, Netezza, Microsoft's SQL Server, MySQL. There are a lot of options out there. Why are so many databases implemented incorrectly? While databases do have pre-existing solutions, if they are not implemented correctly, they can cause you to access information much more slowly than you would like. You would not be able to access or record as much information as you want, and you will end up having to rebuild your entire database because eventually your database will be incapable of handling all that information if its design isn't correct, and it will just not serve the purpose that you want it to. This might mean that it won't record all the information that you put into it as traffic increases. This might mean it might take hours or years even to access or find information that you want, when you could simply access it within seconds or minutes if the database was implemented correctly. Why are they so complex? Well, my understanding of complexity is just a lot of simple things built upon each other that you don't understand. So once you break anything down to its basic root, everything, even complex ideas, become simple. So a database could become complex because you're managing so much information and you just don't understand the information. What are some popular database engines? I already mentioned a few. Oracle, IBM offers a couple. I believe they just bought Netezza. MySQL is another popular option. MS SQL Server from Microsoft, or Azure. I've heard of many Java-based databases as well. However, you could simply Google it and you'll be able to find it quickly. Since databases are so often used, you could easily find a lot of information on it online. So what are the parts of a scalable database design? So a lot of times when you're dealing with databases, you're going to hear a lot of terms associated with them, like OLTPs, staging, OLAPs, data warehouses, ODSs, CIFs, data marts, ETL, acquisition, integration, distribution layers, or there's also other terms that are used, which are based on the company you're working for. They might have jargon specific to their group of people, even. However, right now I'll just be dealing with commonly used terms. So let me start with OLTP. And OLTP stands for Online Transactional Process. Basically, this is a database that your customers deal with directly through an application or a website. This is the actual front end database that works with transactions. And by transactions, I mean interactions with your customers. So if you understand a bit of MySQL, or SQL, this will include insert, update, and delete operations on a larger scale. So it's constantly accessing information, managing information, um, updating information. It's basically your front end database. Um, then you have another database called the OLAP. This stands for Online Analytical Processing Database. This is basically a database with historical information. So this is a newer concept. I think it dates back to the 1990s. So it's newer than OLTPs, and OLTPs were the original database, developed by, I believe it was Boyd. I might be wrong. So basically, what OLAPs do is take information from an OLTP every once in a while, so that the OLTP will be able to remain small and will not have to contain information that it doesn't use, and it'll store it historically in the OLAP. They have different structures because they serve different purposes. An OLAP's data is normally taken on occasion from the OLTP and clears it out, and then it stores vast amounts of information. So the OLAP will be bigger than the OLTP, and while you'll be inserting a lot of information from the OLTP, you will be doing analysis on the OLAP. So the OLAP will be the database that you'll use for doing data mining, for generating reports, for basically analyzing historical trends based on your customers' interactions with the OLTP over time. So by keeping the OLTP smaller, it'll allow you to have a faster front-end database, and while having an OLAP, you will also be able to analyze, not lose any information, and have all that information that you want to analyze at the tips of your fingerprints. And then by mining that information and analyzing that information, thus the name, it will allow you to derive information from it based on customer patterns and buying patterns over time, and over whatever way you want to dissect that information, and get other useful trends or discover new things about your customers that you can use in your business. Another database that you might hear mentioned once in a while, although it doesn't always exist, the OLAP doesn't always exist either. However, for bigger companies, they will have these two stages. Another database that is often used is called the staging database. Basically, what a staging database is an intermediate database between the OLTP and OLAP, and it is used to clean the data, verify the data, and perform any operations on the data that might make it easier to process before sending it off to the OLAP. This is data cleansing. This is generating metadata about the data, and verifying the data is correct. That would happen in the staging database, which is a separate database. And then it would go to the OLAP. Sometimes you might hear a term called pre-staging. The pre-staging database is a database prior to the staging database. Basically, what the pre-staging database does is take information from the OLTP, and on occasion, there might not just be one OLTP. There might be many OLTPs. The reason why there might be many is because you might have one for a California region, you might have one for a Florida region, you might have one for an Atlanta region. Basically, you would have OLTPs to handle traffic from different regions in order to better handle mass amounts of traffic. And then you would have pre-staging to gather the information from all those different OLTPs and put it in one place. And then you would be able to access that information all at once from all the different locations and move it into your staging database where you clean it. So basically, a pre-staging database is a database that gathers information into one area from different OLTPs. Then you have your a term called the data warehouse. A data warehouse is basically another term for an OLAP, which is the historical repository, or basically the database that is used for analysis. You might hear the term operational data store. Basically, an operational data store is a smaller version of your OLAP. So often you'll have an OLAP with vast amounts of information, and then your business will want to be able to analyze specific data in your OLAP for, like, say, the last month at a faster rate. They don't want to have to iterate through the large amounts of tables in your OLAP. So they'll make another database that is analyzed, which is smaller than your OLAP and contains a subset of the information in your OLAP for a smaller period of time, called the operational data store. The operational data store will be used to generate reports on a more frequent basis, and basically is a faster version for a smaller set of information than your OLAP. A corporate information factory, or a CIF, is basically it encompasses your OLAP, your ODS. It's a combination of the two. It's basically all the different methodologies used to implement the historical database and generate and whatever is used for mining that data. So a corporate information factory, just like its name says, is information factory. It contains all that information and it processes all that information. It's used for processing, and it's sort of like a factory. Then you have your data marts, which are basically subsets of data warehouses. So your data warehouse, which is your OLAP, basically has all these databases that are set up in such a way that they're able to analyze data quickly in particular and answer particular questions with the data that you took from your front-end database, or the OLTP. So basically, a data mart is a part of data warehouse that doesn't answer all the questions, but only a few. So it's a subset of your data warehouse. I'll get further into that in later lectures, although it is vague for now. And you might hear the term ETL, which stands for extract, transform, and load. Basically, what ETL is any process that is used to move information in between databases. So you might have, as the term stands for, ETL, extract, it takes information out, transforms, it performs any transformations on the data, and then it loads into another database. It's a pretty straightforward term. Acquisition, integration, and distribution is another term set of terms I've heard before. Basically, all that is acquisition is another term for, or a general term for, OLTPs, wherever you're accessing data. It's an abstract term for that. And integration is basically just like your pre-staging database. It takes information from different areas and puts it in one spot. And distribution is another term used for loading it into your OLAP, or distributing it to other places. all these. So since you look at it as the data flows from your OLTP to your staging to your OLAP, or which is the same as your acquisition, integration, and distribution layers, you could consider these layers, since uh, you could look at it like cutting open a cake. When you first look at the cake, you have the outside, which is the chocolate. That could be sort of thought of as your OLTP or your acquisition layer. Then you cut down a little bit more, and then you get to the floury white part of a cake. Let's pretend it's white on the inside. So you could consider that your staging database, since it's on the inside, or where all the flour is condensed. And then you get even further down, and here's where the cake method representation falls apart, but just pretend it has a cream center to that cake. And then you could consider that your distribution layer, or your OLAP. So basically, when people refer to layers, it is like referring to levels at which the information flows through. So by implementing these three layers, your database becomes more scalable, and you're able to do more with your information. I will describe how later on. Okay, so you might hear another term often used. It is the cube. I took a diagram of a cube and I put it here, but basically what a cube is a system that is built on top of your data warehouse, or your OLAP. So what the cube does is it takes the data from your data warehouse and reorganizes it and creates information about the data within it. And it's structured in a different way from your data warehouse. By this, I mean that it isn't a relational database model that is being used in the cube. It is a multi-dimensional model. And the reason why people often use this cube is because once you put your information in a multi-dimensional model, especially a historical repository, you will experience a 16 to 36 times increase in the speed of your database, data warehouse. That means you'll be able to access that information that much faster. You'll be able to process that information and analyze it that much faster. So a cube is a very powerful structure. The downside of using cube is that it's exponentially bigger. It has a phenomenon associated with it called data explosion. However, the fact that you can access and process information that much faster than using a data warehouse that utilizes the relational database model makes it very useful. And since hard drive space isn't as much of a problem these days for big companies, and storage space is very cheap, and every day it's becoming faster, having a cube is something you should look into, especially if you want to base reports off of your cube or your relational data base. Okay, and what do I mean by reports? With Microsoft SQL Server, it comes with a program called SSRS. SSRS is basically a tool suite that allows you to quickly and efficiently build reports based on the information in your data base or your cube. So basically you can design information-rich reports that have graphs, have data analysis in them, have time analysis in them, and parse it and organize it in any way a customer deems fit. What does this mean? And why would you use them? Because the reason you use reports is to present information in a way that people can understand. So by creating these reports for users, you could basically, you will have a method of displaying all this information to the end user. in a way that they could understand, which is a lot more useful than you can imagine. A lot of big companies use it. I am aware of many Fortune 500 companies that have used reports. They might not use SSRS, they might use something like Crystal Reports or various other suites, but the ability to understand the vast amount of information in your data warehouse and present an toned down version of it that answers or gives you information on what you're looking for is a very powerful ability. And this is the power of reports. So basically, that is what I meant. So now I'm going to get a little bit into database design. This is just an overview. What do you want your, whenever you have make a database, you have to ask yourself, what do you want your database to do? Do you want it to model your company so you can track all the processes that are going on in the database in your company? Or do you want it to serve a toned down subset of services for like an application, so you don't need it to do everything? And then after you know what you're going to do, you can start designing your database using a design tool like ERWin or MS Visio. I like ERWin because you could use it with Oracle or MS SQL, and you can reverse engineer. ERWin is just more flexible. And then when you're designing it, you had to specify the different primary key and foreign key constraints. These become important later on. The reason being is because if you properly design your database, it'll be quicker for extracting information. You will be less likely to have redundant data or data that doesn't match up. So you might have duplicates of data and various other things. So by properly designing your database, you will run into less problems in the future. If you have a badly designed database, the problems will propagate into the future. You could also forward engineer the schema using these tools to a database engine, although I don't recommend that. I recommend coding out the schema yourself so you'll have more control over what it does and you'll know exactly what it's doing. When you generate the schema, it tends to generate along with it a lot of junk code. You could implement constraints. That means you could limit what information is put in. This will also prevent dirty data or data that, because people that are entering information to your database are going to make mistakes since they're human. You can implement constraints to prevent their mistakes, to from going into your database and confusing people later on. So you could handle it ahead of time, and you can create a data warehouse if your company deems they have a need for it, and this will also cause numerous benefits. If they need a staging database, for example, if they have multiple locations for their database and they need it all in one area and they need to clean it and stuff, do you need to, are you going to implement the ETL processes? You're always going to need ETL processes to move data between databases, and you're going to have to decide how you want to implement them, because a good implementation of ETL process will be quicker, and a bad ETL process will take a lot more time and it could cause problems later on by locking up your database, etc., etc. Do you want to create reports from your database? You got to ask yourself that. Those are basically a lot of the things that go into creating database design. As you can see here, I took a better diagram off the net. I forgot from where. These are OLTPs. Basically, your OLTPs are your data sources, so you can take it from different areas. So here it takes it from ERP, SCM, and CRM. Those are other terms for data managing tool suites. And then it's using the ETL to combine it into a useful information and storing it together and storing it in the data warehouse. So that is an overview of what happens during and things about databases and their setup. Major roles in database design teams. While this is not strictly abided by, always, because every company runs differently and different teams sometimes might not even have really defined and strict rules. However, um, the main roles in a lot of teams are database development teams is business analyst. Basically, what a business analyst does is he talks to um, the clients and the company and whoever needs to be talked to. He understands what they're saying and has an understanding of the database and database design. And he comes up or she comes up with a set of rules and um, basically they come up and understand what the company needs and they basically take what the company needs and the clients need or the customer needs and they analyze that and um, present it in a way that the database architects and the other people on the team um, can understand. The business analyst is very important because once they present the information in a very understandable way, their understanding will influence the design, the setup, the ETL, everything with regards to the database. So basically, they come up with the questions that the customer needs answered, and any possible questions they might need answered, and then they will help with various other roles when designing the database. A data analyst is another member you might hear about. A data analyst is a person that analyzes vast amounts of, they have an understanding of the data. So basically, what I mean by this is that a data analyst will allow for you to have, will be able to read the information because what they have learned about database design is that a lot of times simply understanding different regions of a database can lead to um, a lot of time uptake. So there could be problems with data, there could be problems with the actual information. So data analysts could look through the data and they'll see anomalies because they'll have a deeper understanding of that information in the database. You could there are database architects, and just like architect, they're the ones that design the database. So they'll design the data models, they'll design the foreign key and primary key constraints, and they'll say how the database information should, the databases should be set up based on what the business analyst tells them. You'll have your developer, who's the one that'll actually do all the code. They'll create the ETL processes, they'll create the schemas, or whatever else. You'll have your QA. What the QA does is the QA or quality assurance is basically a group of testers. They analyze the system and make sure it does what it's supposed to do. So they'll have a deeper understanding of everything with regards to the database. And then you'll have your team lead. Your team lead is basically a person that creates the various documents and organizes your developers and QAs and makes sure that they get the job done on time. As I said, that every company works differently. You might not have all these roles, but at the same time, there's always going to have to be people that fulfill these roles and achieve them. Some commonly used tools, like I said in the beginning, are Oracle, SQL Server, IBM DB2. I believe IBM also bought Intesa recently. And that is all for this overview of databases. I hope you enjoyed it and I hope this will help you. And that is all for now.